Hi, my good evening, Sujita. Sujita, are you getting my voice?
Yes, sir.
Yeah, ma'am. So in last class, we discussed about the alkanes. So sorry for the yesterday's class, my here. So suddenly my system was updated. I didn't check it out here. So after updating that one, something happened, some technical issues there. That's why I didn't take the class. Okay. So now, so today we are going to discuss about the alkenes. Okay, we already completed the alkenes. Now we'll discuss about here alkenes. So what is meant by the alkenes, ma? So which we can call as alkenes. So alkenes are nothing but here unsaturated hydrocarbons. Alkenes are nothing but here unsaturated hydrocarbons. Unsaturated hydrocarbons. Unsaturated hydrocarbons are we can call as a alkenes. Alkenes also we can call as a olefins. Alkenes also we can call as here olefins. Olefins are nothing but oil forming. Okay, so olefins are nothing but here oil formation and at all. Okay, because unsaturated hydrocarbons are they can be used in the synthesis of polymers also. From polymers also we can prepare some of the oils out here. So that's why we can call as here olefins. Okay, now so what is the another one means here? So what is the general form? What is the simplest molecule of the alkenes means here? CH2 double bond CH2. What is the simplest molecule of the alkene means? Simplest molecule of the alkene is ethene. So what is the general formula of the alkenes? So general formula of the alkenes are CnH2n. So what is the general formula of the alkenes? CnH2n. So this is the general formula of the alkene. Okay. Now, so already we had seen the isomerism. So now I'm not going to discuss about the isomerism and at all. Okay. So in that one isomerism, which part alkenes are they exhibit as a geometrical isomerism. Under the geometrical isomerism, so we studied about the cis and trans isomerism. Okay, so we studied about here cis and trans isomerism. So alkenes are they exhibit as a geometrical isomerism. Okay, and so preparations. So once you check it out the preparation of the alkenes. Preparation of alkenes. So how are you going to prepare the alkenes? So preparation of the alkenes. So we have different methods in the preparation of the alkenes. Okay, so we have here the different methods in the preparation of the alkene. So what is the first method we are having means here from alkynes also we can prepare as alkenes from alkynes. Okay, for example, if you had taken so directly I'm taking as a one example here, so which is one of the most important for the exam point of view example here. So that I'm going to take as a butane. Okay, alkynes. So first one I'm taking as a butane. CH3 bond, C triple bond, C bond CH3. Okay. So butane, which butane means 2-butane. If 2-butane is, it undergoes to the reduction reaction. Okay, 2-butane is, it undergoes to the reduction reaction. If it undergoes to the reduction reaction in presence of Lindlar catalyst. Lindlar catalyst. Sir, what is mean by the Lindlar catalyst and at all means here? Palladium in presence of barium sulfate. Palladium in presence of barium sulfate is called as a Lindlar catalyst. Okay, in presence of barium sulfate, sometimes they are using as a carbon, sometimes they are using as a phenolene. Okay, now so when the alkyne 1-butane 2-butane is it undergoes the reduction reaction with the palladium in presence of so barium sulfate means it gives as a cis-butene. Okay, it forms as a cis-butene. Sir, what is meant by the cis-butene? Cis-butene is nothing but if two identical atoms are present at same side of the double bond is called as a cis-butene. Atoms or molecules are present at same side of the double bond with that we can call as a cis. If the atoms and molecules are they present in opposite direction with that we can call as a trans. Now, so 2-butane. So here another one again. If another reducing reagent. So what is another reducing reagent we are taking in sodium in presence of liquid ammonia. Okay, sodium in presence of liquid ammonia. So this also we can call as a Birk reduction reaction. This also we can call as a Birk reduction reaction. So when the butane 2-butane is, it undergoes to the sodium in presence of liquid ammonia means it forms as here. So trans 2-butene CH3, trans 2-butene CH3 bond CH3 bond H bond H. So whenever you reduced with the palladium in presence of barium sulfate means it forms as a cis product. And whenever you take as a liquid in presence sodium in presence of liquid ammonia means it forms as a trans product. Forms as here trans product. So now you got the clarity?
Yes, sir.
Okay. Next one. So what are the another methods we are using means here? So we can use from the alkyl halides also. Okay, alkyl halides also we can use in the preparation of the alkene. For example, ethyl chloride is there. That means CH3 bond CH2Cl. Okay, so this one is treated with the dehydrating agent. Sir, which one is they act as a dehydrohalogenating agent. So what are the examples of the dehydrohalogenating agents means here? Alcoholic KOH1 we can use. And another reagent, what is the another reagent we can use means here? Sodamide. Okay, and NaNH2. NaNH2 is nothing but here sodamide. These two are they act as a dehydrohalogenating agent. Okay, it is one of the example of the beta elimination reaction. It is one of the example of here beta elimination reaction. That means from beta carbon atom. So the halogen which is attached to the carbon means that we can call as alpha carbon, and adjacent carbon is called as a beta carbon atom. So from alpha carbon atom, one atom, and beta carbon atom, we are removing some the second atom means here that we can call as a beta here a beta elimination reaction. So if you remove two atoms from the neighboring carbon atom space, finally it forms as an alkene. CH2 double bond CH2 is going to be formed. Plus byproduct is KCl plus H2O is going to be formed. If you take it as sodamide means NaCl, and what ammonia is the byproducts is going to be formed. Okay, so this is the one type of the reaction. And what is the another reaction we are having means here? So from vicinal dihalides, remember what is the vicinal dihalides? If two halogens are present at the same carbon atom, adjacent carbon atom, if two halogens are present on the neighboring carbon atom, that we can call as a vicinal dihalides. So when the vicinal dihalides are treated with the zinc metal, when the vicinal dihalides are treated with the zinc metal, means they also form as a alkene, and byproduct they form as a zinc chloride. Okay, and this is the one reaction. So what is the another reaction we are having means here? Dehydration reaction. What is another reaction we are having now? So dehydration. So dehydration is from alcohols. So we are taking as alcohol, ethanol we are taking CH3 bond, CH2 bond OH. If the ethanol is treated with concentrated sulfuric acid, okay, if it is treated with the concentrated sulfuric acid means it undergoes to the dehydration. Dehydration means removal of the water molecule. If you remove the water molecule also, it forms as a CH2 double bond CH2. Okay, so dehydration reaction, beta elimination reactions are example of here. So elimination reaction. According to the elimination reaction, so which product is more stable means here the alkene which is attached with the more number of alkyl group, that it becomes as a more stable. Okay, clear? So
Yes, sir.
what is another concept we are having means here? Coal-based electrolysis process. What is another one means here? Coal-based electrolysis process. Coal-based electrolysis process. Sir, what is meant by the coal-based electrolysis process means here? In this one, we are taking as a sodium malate or potassium malate. That means CH bond COONA, and double bond, single bond here. CH2 alkenes now. CH2 bond COONA and CH2 bond COONA. Okay, since both are, they undergoes to the electrolysis process, H2O and electrolysis process. If they undergoes to the electrolysis process also, they form as an alkene, CH2 double bond CH2 plus. Okay, so Na2 CO3 is going to be formed, plus water molecules are going to be here. Okay, so these are the different methods we are using in the preparation of the alkenes. Okay, and what are the physical properties of the alkenes? What are the physical properties? Physical properties. Sir, what are the physical properties means here? Some are colorless, odorless gases are there. In this one, this means C2 to C5 are gases are there. C2 to C5. C2 to C5 means here in this one, ethene, propene, butene, okay, and pentene, all are the gases are there. From C6 onwards, C6 to C17 carbon atoms are liquids. C6 to C17 carbon atoms are the act as a liquids, and C17 greater than C17 are the act as a solids. Okay, and alkenes are insoluble in water. Alkenes are insoluble in water. They are highly soluble in organic solvents. Okay, they are highly soluble in organic solvents. Organic solvents. They are highly soluble in organic solvents. And boiling point temperatures. So boiling point temperatures also, the mass is increases. Mass and carbon chain length. 1 second, ma. Right, ma? So boiling point temperature and mass, and in this one, mass is going to be increases, and carbon chain length. Carbon chain length. Carbon chain length is increases. Okay, boiling point temperature also is going to be increases. Carbon chain length is going to be increases means here the boiling point temperature also is going to be increases. So branched chains, branched chains are increases. So boiling point temperatures are going to be decreases. Okay, so boiling point temperatures are going to be decreases. In this one important point of the question is the exam point of the question. Sir, what is the exam point of the question we are having in this one means here? Here, we had seen cis isomers and trans isomers. Cis and trans isomers we had seen. If you see means cis isomers are having high boiling point temperature. So which one are having high boiling point temperature? Ma, cis isomers are having high boiling point temperature. Low trans isomers are having low boiling point temperature. Sir, why the cis isomer is having high boiling point temperature means because of surface area is more. Which one is more here? Surface area. Surface area is going to be increases means van der Waals attraction forces is going to be increases, and the boiling point temperature also is going to be increases. So due to that reason only cis isomers are they having high boiling point temperature. Okay, and cis isomers are having low melting point temperature, but trans isomers are having high melting point temperature. So trans isomers are having here high melting point temperature. So because of the having symmetrical arrangement. So whenever they're having the symmetrical arrangement means they're having here high melting point temperature. Got the clarity?
Yes, sir.
Right, ma. Okay. Next. So what are the chemical properties? Chemical properties of alkenes. Chemical properties. Sir, what are the chemical properties means here? First of all, alkenes are it undergoes to the electrophilic addition reaction. What is the first point means here? Alkenes are it undergoes to the electrophilic addition reaction. Electrophilic addition reaction. And second one, so alkenes are they undergoes to the polymerization reaction. They undergoes to the polymerization reaction. Okay, polymerization reaction. Alkenes are they undergoes to the polymerization reaction. Another one is they undergoes to the electrophilic addition reaction. Sir, what are the examples of the electrophilic addition reaction and it all means here? For example, directly I'm taking as an unsymmetrical alkene. Okay, so directly I'm taking as here unsymmetrical alkene. That means CH3 bond, CH double bond, CH2. So this we can call as a propene. This we can call as a propene. Okay, so propene is a symmetrical or unsymmetrical, ma? Suyuta?
Unsymmetrical.
Unsymmetrical. Okay, so unsymmetrical means it follows the Markovnikov rule in the electrophilic addition reaction and at all. Okay, so first we will check it out here step by step. Once you can check it out. First, it undergoes to the hydrogenation reaction. That means reduction reaction in presence of nickel, platinum, palladium. In presence of nickel, platinum, palladium, it undergoes to the reduction reaction means it forms as a propane. CH3 bond, CH2 bond, CH3 is going to be formed. CH3, CH2, CH3 is going to be formed. Okay, next it undergoes to the so here addition of HBr or addition of HCl or addition of HBr. Addition of HBr is it is the electrophilic addition reaction. Okay, it follows the Markovnikov rule. According to the Markovnikov rule, bromine is going to be attached to the second carbon atom. Okay, so what is meant by the Markovnikov rule means here? According to the Markovnikov rule, the alkene which is having less number of hydrogen atoms, okay, the negative ion is going to be attached. The carbon which is having less number of hydrogen atoms in alkene is called as here Markovnikov rule. So bromine is going to be attached to the second carbon atom, hydrogen is going to be attached to the first carbon atom. Then it forms as a 2-bromo-propane. It forms as here 2-bromo-propane. So this we can call as a Markovnikov rule. Not only addition of hydrogen halide, addition of water molecule. Addition of water molecule also it follows the Markovnikov rule. If it follows the Markovnikov rule means it forms as a secondary alcohol. Okay, and oxymercuration demercuration reaction. Oxymercuration and demercuration reaction. Oxymercuration and demercuration reaction. Oxymercuration demercuration reaction also finally you will get as a product is so secondary alcohol only. It is also follows the Markovnikov rule. Okay, so what is the reagents we are using in this one means here? So one is we are using as a mercuric acetate. So which one we are using, ma? We are using as a mercury acetate. Okay, and so oxy, ma, here one more is there. Okay, hydroboration oxidation reaction is there. Hydroboration oxidation reaction. Hydroboration oxidation. Sir, what is meant by the hydroboration oxidation reaction means the reaction is carried out in presence of diborane B2H6 in presence of tetrahydrofuran, and the reaction is going to be completed in presence of hydrogen peroxide. The reaction is going to be completed in presence of hydrogen peroxide. So when the alkene is treated with so diborane, it forms as a primary alcohol. CH3 bond, CH2 bond, CH2 OH. So this we can call as a primary alcohol. Whenever you're getting as a primary alcohol, that it follows here anti-Markovnikov rule. Okay, that it follows here anti-Markovnikov rule. Not only this one here. So one more addition reaction also it is the addition of hydrogen bromide in presence of peroxides, either hydrogen peroxide, benzyl peroxide, acetyl peroxide. So in presence of any peroxide also, it is also converted into the primary alkyl halide. Okay, CH3 bond, CH2 bond, CH2 bond, Br. Now you got the clarity here. So all these are the different types of the addition reactions we are having. Okay, right, ma?
Yes,
And
sir.
identification of the alkenes are there. So how are you going to do the identification test of the alkene? So we have a two tests are there. So unsaturated one. So Detection of the double bonds. Detection of the double bonds, how we are going to identify means here, bromine in water. Br2 H2O, bromine in water. Okay, so bromine in water. When the alkene is treated with the bromine in water means, actually bromine in water is in brown color. So which color ma here? It is in brown color. So whenever it is treated with the alkene, okay, it forms CH3 bond, CH bond, CH2. So it forms as a vicinal dibromide. Okay, it forms as a vicinal dibromide. So and it gives us a colorless solution. It gives us here colorless solution. So what is the colorless solution? It is that here, based on that one, we can identify that the given compound is unsaturated or saturated. Okay, and it gives as a trans product. Trans product. So bromination reaction is the example of here trans product here. Clear? And one more also it is there. Bayer's reagent one it is there. So what is mean by the Bayer's reagent? What is mean the Bayer's reagent? Bayer's reagent also it is used in the detection of unsaturated site. So what is mean the Bayer's reagent means alkaline KMnO4. Alkaline KMnO4. Alkaline KMnO4 also is called as a Bayer's reagent. So Bayer's reagent also it is used in the detection of the unsaturated site. Actually, alkaline KMnO4 is in purple color. So which color it is that KMnO4 actually? It is purple color. So for purple color, if you add 2 to 3 drops of, or first you are taking as some organic compound in a test tube. For that only, if you add 2 to 3 drops of the alkaline solution or Bayer's reagent means it decolorize. Okay, it decolorized. So wherever it is going to be decolorized, it is converted into the diol. So that means what is the product it is going to be formed is CH3 bond. Wherever the double bond it is there, by breaking of the double bond, that pi bond, it forms as a 2 new sigma bonds. Forms here 2 new sigma bonds. Now we got the clarity. So it forms as a 1, 2 diol. So this one is the cis product. This is called as a cis product. Sir, how you are telling that means alkaline KMnO4 it gives as a cis product. Addition of bromine is it gives as a trans product. And osmium tetroxide reaction with OSO4. It is also gives as a same product only. It is also formed as a 1, 2 diols. It is also formed as here 1, 2 diols. Now we got the clarity.
Yes, sir.
So all these are the different types of the reactions we are having. Okay, clear? Right, ma? So this about here alkenes. Okay, and in this one more important reaction is that. So what is the another important reaction we are having means here ozonolysis reaction. Ozonolysis reaction. CH3 bond, CH double bond, CH2. Okay, ozonolysis reaction. So O3 reductive hydrolysis. Okay, reductive hydrolysis. Directly I'm telling as a shortcut mark. Okay, so wherever the double bond it is there. So 1 second mark. Right now. So what is meant by the ozonolysis reaction means here? So when the alkene is treated with the ozone molecule and it undergoes the reductive hydrolysis means it forms as a respective carbonyl compounds. Have you read about this one? Same reaction again we are going to study about the study in preparation of aldehydes and ketones. Have you read or not? Aldehydes and ketones also we studied same reaction in the preparation of carbonyl compounds. In the preparation of the carbonyl compounds also we studied same reaction. Sir, how are you going to prepare the carbonyl compounds means what is the ozonolysis reaction mean? Simple shortcut I will tell you. Wherever the double bond it is there, you can break that. So both side you can add as a 1,1 oxygen. Both side you can add as a 1,1 oxygen. If you add 1,1 oxygen means let us see ma. Okay, so let us see. So in this one. If you add 1,1 oxygen means what is the product it's going to be formed ma? What is the product is going to be formed?
CH3, CHO.
Very good, pa. CH3, CHO plus HCHO. HCHO. So this we can call as a acetaldehyde. This we can call as a acetaldehyde. Okay, this we can call as a formaldehyde. This we can call as a formaldehyde. Okay, so all these are the different reactions we are having. Clear? You got the clarity, ma?
Yes, sir.
Okay, so this is about the alkenes. So tomorrow we'll discuss about the alkenes chapter. But just I have a small work. I'm getting some calls. Okay, so we'll
Okay, sir.
continue. Correct. Thank you, ma. Okay, remaining part will
Thank you,
continue.
sir.
Yeah, you
Okay,
will.
sir.